Hello everyone, welcome back to another video for the series. I'm Inakyu, and today I brought a very fun and interesting problem from KMO. And the reason why it's interesting is because this problem was so easy that these kind of problems are sometimes called like free problems. They're not like the official name, but uh, those problems were created to increase the mean score of that year. So I think every single student who took KMO in the year 2024 got this problem correct, I think. Because I was able to solve this problem in like 2 minutes or less than 2 minutes, excluding the time drawing the diagram. So I think they just gave this problem because it would be so sad if students got like 0 points on an exam. So yeah. So for this problem, I'm going to share my personal solution, and I'm also going to share a random solution that I found in the internet, and they're both short, very short. So yes, I would like to share them. First of all, let's draw the diagram. Three distinct points A, B, X lies on a circle with center O. So you have a circle. Yeah, and A, B, X. Let's call this A. Let's call this B. Let's call this X. This point. With center O. So this point is the center. Yeah. A, B, O are not collinear. So nice. And let omega as given omega as the circumcircle of ABO. So ABO one more here. And a circle. Whoa. Whoa, this is perfect. Okay. This is omega AX and BX. So AX and BX yeah, I don't quite like it, but there's no other choice. Okay, so this point is C, and this point is D. So this is C and that is D. Show that O is the orthocenter of triangle CXD. This one, more. And then last one. Yeah. Then for me, wait, before doing that, I quickly want to copy the diagram so that oops. I don't have to redraw it again later. So first of all, I drew an extra line like this. And the reason for drawing this is because if AD equals dx and BC equals cx, then O is the ortho center of triangle CXD. And the reason is because, so let's say there are 2 points, and let's draw them. Let's draw lines that are equidistant from them. So I think maybe I think it would be better to describe it using radical axis. Yeah, I'll just use radical axis to quickly explain that why, if these are true, then DO and CO are perpendicular to AX and BX respectively. So say we have 2 points like this, draw a huge circle. Say we have 2 points like this, draw a circle like this, and draw another circle like this, where this is the radius. So they have the common radius. Now the definition of radical axis is the collection of points, or I don't know, like trace of points. I don't know if they say it as trace, but in Korean they say like 점들의 자취. So it's technically a trace. So the set of the set, I think that's a good word. The set of all points P such that PA squared minus PA squared, the power of A at P equals the power of B. I think this is the notation that they use. It's been a while since I did radical axis. I quite forgot, but I think this is correct. Yeah. So this means PA squared equals, please comment down below if this is wrong. I kind of forgot how it works, but I'm pretty sure this is correct. Therefore, in this case, the radical axis is a collection of all points that are equidistant from A and B. And notice that radical axis is a straight line that passes through these 2 points, and that is always perpendicular to AB. So let's take a look at A and X. If we already know that O is on the radical axis. If D is if AD equals dx, that means D is also on the radical axis, and because radical axis is a straight line, we can conclude that this is the radical axis of 2 circles. Yeah, 2 circles that we didn't draw it here, but based on points A and X. That is, this is 90 degrees, So DO, connecting DO and AX are perpendicular to each other. But notice that all of this is symmetric. So we actually don't need to prove the latter one, we only need to prove the AD equals DX. Then we're done. Therefore, it suffices to prove that it suffices to prove that DO let's compare them with the angle. So it suffices to prove that this angle equals this angle. So so this is the only thing that we need to prove. This equals this. So I did angle chase. I chase the angles. If this is alpha, let's call it alpha. This is 2 alpha. Let's call this one beta. Then if this is beta, if this is the center, this angle is 2 beta. And let's take a look at so let's compare them. But first of all, we kind of want to write a relationship, write an equation that shows the relationships between alpha and beta. So this angle right here is 180 minus alpha minus beta. This angle is 180 minus alpha minus beta. If this is beta, this is 2 beta. Wait, how did I continue from here? Oh my goodness. This is this is alpha. 2 alpha. No, because I remember doing something like minus alpha minus beta equals 180. I think it was minus 2 beta. I remember doing something like this, and then I finished the proof. Therefore, alpha equals beta. I don't remember how I did it. Where did I get 180 minus 2 beta? Oh no. So this angle is 180 minus 2 beta. This one and this one is 180 minus 2 beta. But can we write this in terms of alpha and beta? Yes. I remember. I found it. Yes, sorry. So just scratch that. So first of all, sorry, we know that this is 2 alpha. This angle is 2 alpha. Therefore, let's draw this line right here. Oops. Let's draw this line. this angle is also 2 alpha. Therefore, this is alpha, 2 alpha, this is 2 alpha, this is true, and therefore, where's the center? This one. This, like this. This angle right here is 2 times 180 minus 2 alpha. Yes. And I just remember that this was the mistake that I made while solving it. So I was not able to continue from here. So I found it. Yes, I found it. This one. Oh my goodness, I just solved it, but I cannot believe that I forget things so quickly. So we just need to find this angle because that plus that equals, yeah. So what is this angle? This angle. This angle is actually equal to beta. Because look at the chord CD. Is equal to beta. In other words, yes, I remember 2 alpha plus 180 minus alpha minus beta equals 180. Therefore, alpha equals beta. And that completed the proof. So we are done. Alpha equals beta, this equals that, and the same thing because the entire process is symmetric. BC is also equal to CX, and therefore we proved that O is the orthocenter of triangle CXT. Yes, this was a solution using some of the concepts from radical axis, but more like angle tracing here. And sorry, I'm allergic to seasons. Cannot, concentrate well today. Don't wanna blame seasons for it, but yeah. The next solution, I found the solution to be really interesting because they did this. So first of all, let's draw a line like this. They use the interesting property that I think I introduced last video. So if we call this theta, we know that this is 180 minus theta, this is cyclic, so this is also theta. So ABOC is cyclic, so 180 minus theta and theta. That is true, that is correct. From here, we know that this is actually this angle right here. So notice that O is the circumcenter. So this plus that is equal to 90 degrees. In other words, this plus this is equal to 90 degrees. So therefore, this angle right here is 90 minus theta. So just draw it like this triangle is 90 degrees. We could do the same for D, and we completed our proof. Yeah. So I think this problem, although it was not a difficult problem, I really enjoyed reviewing about few properties in geometry and also radical axis. And then thank you so much for watching this video, and I'll come back with another very fun and interesting video tomorrow. Thank you, and see you tomorrow. Bye.